Now in this problem, we're asked to write the formula that correctly represents the sequence. And from our class, we know that there's two types of sequences that we will deal with. We know that the arithmetic sequence is whenever you add a constant number each time to get the next term, whereas our geometric sequence is you multiply by a constant number to get each term. So we need to ask ourselves, to go from 5 to 8, in this case we would add 3. Let's see if that pattern continues. To go from 8 to 11, we still add 3. 11 to 14, we still add 3. And we see to get from one term to the other, we constantly add 3. So then we would reference and figure out, okay, what is the formula for an arithmetic sequence? In general, it's the nth term is the first term plus the common difference times n minus 1. Now I'm going to give everybody a moment to attempt on their own paper. What is our common difference? What is our first term? And then we'll have this formula written down. Now our common difference is 3, because we add 3 each time to get to the next value. Our first term is the first term listed 5. So we have our general formula, a sub n is 5 plus 3 times n minus 1. Now in our next problem, it says write the first 4 terms of the geometric sequence, where the first term, a sub 1, is 8, and the common ratio, r, is equal to 1/2. Now I'd encourage you to pause the video now, attempt this problem on your own, and then unpause to check your work. Now the first thing that we notice is they did tell us it's geometric. They told us the first term, they told us the common ratio. So we know the first term that was given, it's 8. But then since it's geometric, to get every next term you multiply the previous by 1/2. So 8 times 1/2 is 4, that's our second term. To get to the third term we say 4 times 1/2, which is 2. To the fourth term, 2 times 1/2, which is 1. Now in our next problem, we're given a sequence, 2, -4, 8, -16, 32, and we're asked to write a formula that represents the sequence. I'd encourage you to pause the video, attempt the problem on your own, and then unpause to check your work. Now the first thing we need to ask ourselves is, do I get to the next term by adding or multiplying? So in order to go from 2 to -4 by addition, I would have to actually subtract 6. But we see that pattern doesn't continue, because if I was subtracting 6 again, I would get to -10, not 8. So in this case, I've eliminated arithmetic. I'm not adding the same amount each time, so I must be multiplying. So let's see. What would I multiply 2 by to get to -4? I would multiply by -2. Let's see if that pattern holds. -4 times -2 is +8. 8 times -2 is -16, so the pattern's holding so far. -16 times -2 is +32. So that means we have a geometric sequence where our first term was set to be 2, and we determined the common ratio, our multiplication, is -2. And we know the geometric sequence has this formula. A sub n is the first term times the common ratio to the n minus 1. So to find our formula, we just fill this in. A sub n equals the first term 2 times the common ratio -2 to the n minus 1 power. And we'll make sure it's clear that this is in the exponent, not multiplication. So in our next problem, we're asked to find the arithmetic sequence if they've told us that the first term is 4, the common difference is 5, and they would like us to find the 16th term. Now of course you could write out a list of the first 15 terms and then add 5 to it and get the 16th term, but that's rather time consuming, so my hint for everybody here is that you would work based off of the formula. If you can write a formula for this arithmetic sequence, then you could plug in when n equals 16 and you'll get your exact answer. So I'd encourage you to pause the video, attempt this on your own, and then unpause to check your work. Now we know our formula based on the given information. A sub n is generally 4 plus the common difference of 5 times n minus 1. So if I want to find the 16th term, that's going to be equal to 4 plus 5 times 16 minus 1. And we would get 79. Let's similarly attempt our next problem. For the geometric sequence, if the first term is 3 and the common ratio is 4, find the 7th term. Again, you could just list this out until you get to the 7th term, but by writing the formula based on the given information, we could find the 7th term in perhaps a more efficient way. So I'd encourage you to pause the video and attempt on your own. Now for a geometric sequence, we write down the formula for geometric sequence. It is always the first term times the common ratio raised to the n minus 1 power. So here we have the 7th term is guaranteed to be the first term times the common ratio raised to the 7 minus 1 power. So that's 3 times 4 to the 6th. Now 4 to the 6th is 4 times 4. Okay, let me just verify that. So we have 4 raised to the 6th power is definitely 496. 496 multiplied by 3, 12,288. Now in our next problem, we are shown 4 different sequences, and we want to determine which ones are going to be arithmetic and which ones are geometric. Remember, arithmetic sequences, you add or subtract each time to get the next term. Geometric, you multiply or divide each time to get the next term. So I'd encourage you to pause the video, attempt these on your own, and then unpause. So here at first we decrease by 10 and then we decrease by 5. Since it's not changing by a constant amount, it's not arithmetic, but it is getting multiplied by 1/2 each time. So we've got a first term of 20, constant multiple or constant ratio of 1/2. So this is definitely geometric. Next up, I keep subtracting by 5. So I keep adding or subtracting to get the next term. That's the definition of arithmetic. Now for the next one, I would multiply 5 by 3 to get to 15, but we see that pattern isn't maintained because 15 times 3 is 45, so it's not going to be geometric. Instead, it looks like we're adding 10 each time. So we have arithmetic. And here, 5 times 3 is 15, times 3 again is 45, 45 times 3 is 135, so that would be our geometric.